this video we will look at cache memory, what it is and why we use it. Let's start off by looking at how quickly we can empty this bottle. As you can see, because of the narrow neck, it takes a little while to empty. If we take a bottle with a wider opening, as we have here with this one with its top cut off, then we'll see it empties much more quickly. Here, the opening is as wide as the bottle we've just looked at, but there is a narrow section in the middle where I've stuck on the top of the previous bottle. Let's see what happens when I empty this bottle. Even though the opening is wide, the narrow section in the middle is limiting the speed at which the water can get out. There is a similar principle in computing. In a computer system, the overall speed at which data can travel is limited by the slowest part. We call this, appropriately enough, a bottleneck. The CPU works at an extremely fast speed. Whilst RAM is much quicker than the hard drive, its speed is no match for the CPU. This causes a problem because the RAM becomes a bottleneck. It doesn't matter how much faster the CPU can process data if the computer is limited by the time the data takes to get to and from the RAM. There is, however, a special type of RAM called static RAM that is much quicker than normal RAM. While static RAM is much quicker than the main RAM used in your computer, it does have a number of disadvantages, the most significant of these being its price. Static RAM is much more expensive than normal RAM. Fortunately, there is a solution. We use a much quicker static RAM as cache memory, spelt C-A-C-H-E. We put the cache between the main RAM and the CPU. To maximise the speed benefit, we put it as close to the CPU as we can. In fact, the fastest cache memory will be on the CPU itself. We only use a small amount, but we use it to store recently used data and data likely to be frequently used. Computers often use the same instructions many times, for example when programs have a loop or work repeatedly on the same data, so it makes sense to keep the frequently used stuff in faster memory. This allows the CPU to check the fast cache for data first. If it finds it, it doesn't have to wait for the much slower main memory. The larger the cache memory, the slower it becomes. To get around this, we have different levels of cache memory. The fastest, level 1, is smallest and closest to CPU. This will store the most frequently accessed data and is checked first. The level 2 cache, which is slower, but still much quicker than the main memory, is bigger and further from the CPU. This will contain the next most frequently accessed data and is checked after the level 1 cache. Some modern processors may have 3 or more levels of cache.